Hello everyone, this is Kalpana here. In this video, we are going to solve a differential equation from higher order linear differential equation. So let's get going. Problem. Solve d square minus 1 into y equals to x square sine 3x. Firstly, let's find order and degree of the given differential equation. Identify the highest derivative here. D square is the highest derivative, so order will be 2. And highest power of the highest derivative is a degree. Degree is 1. Or just write the given differential equation as d square y minus 1 into y equals to x square sine 3x. We know that d is a differential operator. Then d square will be d square by dx square. So we can write our equation as d square y by dx square minus y equals to x square sine 3x. Here d square y by dx square is the highest derivative, so order will be 2. And highest power of the highest derivative is a degree. Degree is 1. Now coming to the problem. Given differential equation, d square minus 1 into y equals to x square sine 3x, which is in operator form. F of d into y equals to q, where f of d equals to d square minus 1 and q equals to x square sine 3x. Now we need to find the general solution to the given equation, which is given by y equals to yc plus yp. Here yc is a complementary function and yp is the particular integral. We'll find yc using the roots of the auxiliary equation of the homogeneous equation of the given non-homogeneous equation. By putting RHS to 0, we'll get f of d into y equals to 0, which is the homogeneous equation of our given non-homogeneous equation. And we'll find yp using 1 by f of d into q. So firstly, here we are going to find yc and yp. The auxiliary equation of f of d into y equals to 0 is f of m equals to 0, where f of m equals to, we have f of d square minus 1. Let's replace differential operator by m, so that we'll get f of m equals to m square minus 1. Then our auxiliary equation becomes m square minus 1 equals to 0. Now we can write this 1 as 1 square. And this is of a square minus b square form, so we can write it as a plus b into a minus b. Now equate each factor to 0. M plus 1 equals to 0, m minus 1 equals to 0. From m plus 1 equals to 0, we'll get m equals to minus 1, and from m minus 1 equals to 0, we'll get m equals to 1. So m equals to minus 1 and plus 1 are the roots of our auxiliary equation. The roots are real and distinct, otherwise we can call them as real and different. Okay. Therefore, m equals to minus 1, 1 are the roots of f of m equals to 0, our auxiliary equation, which are real and distinct. We know that when two roots are real and distinct, say m1 and m2 are real and distinct, then yc will be one constant into e power 1 root into x plus another constant into e power another root into x. Now let's write our complementary function. Yc equals to one constant into e power 1 root into x plus another constant into e power another root into x. Then yc equals to c1 e power minus x plus c2 into e power x. So we got yc now. Let's find yp. Particular integral. find particular integral using 1 by f of d into q. We have f of d into we have f of d and q. Where f of d is d square minus 1 and q is x square sine 3x, right? And this is of 1 by f of d into x power m into sine ax form, right? We have Euler's formula. E power I theta equals to cos theta plus I sin theta. When theta equals to 3x, we'll have e power I into 3x equals to cos 3x plus I sin 3x. Here cos 3x is real part of e power I into 3x, right? Real part of e power I 3x. And sin 3x is imaginary part of e power I into 3x, right? So, we can write yp as, here we are having sin 3x, right? So, we can write it as imaginary part of e power I 3x, right? I'll write it as imaginary part of 1 by d square minus 1 x square into, we'll just replace sin 3x by e power I 3x. This equals to imaginary part of 1 by d square minus 1 into x square into e power, I can write I 3x as 3ix for my convenience. And this of 1 by f of d into e power ax into some v form, right? We'll shift e power ax towards left by replacing d with d plus a, and later we'll operate b with 1 by f of d plus a, right? Now compare e power I 3ix with e power ax, then for a equals to 3I, we'll find d plus a is equals to d plus 3i. Okay, we'll shift e power 3ix here by replacing this d with d plus 3i. This becomes imaginary part of e power 3i into x into 1 by, replace d with d plus 3i, you'll get d plus 3i whole square minus 1 into v x square. This is equals to imaginary part of e power 3ix into 1 by, expand d plus 3i whole square using a plus b whole square expansion, we'll get d square plus 3i whole square plus 2 into d into 3i minus 1 into x square. This is equals to imaginary part of e power 3ix into 1 by d square plus 3i whole square is 9i square plus 2 3s are 6 into I into d minus 1 into x square. This is equals to imaginary part of e power 3ix into 1 by d square plus 9 into, since we know that I square equals to minus 1, so replace I square by minus 1 here, plus write the remaining terms as it is into x square equals to imaginary part of e power 3ix into 1 by d square plus into minus 9 into 1 9 plus 6id minus 1 into x square. This becomes imaginary part of e power 3ix into 1 by d square plus 6id minus 9 minus 1 is minus 10 into x square, right? And this of 1 by some function of d into x power k form, right? And in the denominator you are having terms which is in descending order. So now let's take the lowest degree term common from all these three terms. Okay. And also for k equals to 2, we'll have only values for d of x square and d square of x square. We'll get derivatives till d square because we are having k equals to 2 here. Okay. And higher derivatives from d cube will be 0. We'll see that later. Now take the lowest degree term common from all the three terms of denominator is equals to imaginary part of e power 3ix into 1 by, see, in the first two terms we don't have 10, so what we'll do is we'll just multiply and divide 10 to the first two terms, because in the next term it will be easy to take common, right? Or let's take minus 10 common. Okay, into x square. This is equals to imaginary part of tix into 1 by, now take minus 10 common from these two terms, we'll get minus 10 into d square plus 6id by minus 10 plus 1 into x square is equals to imaginary part of e power 3ix into, we can write this as 1 by minus 10 into, we can write d square plus 6id by minus 10 as minus of d square plus 6id by 10 plus 1 into x square. This becomes imaginary part of e power 3ix into, now split this fraction as 1 by minus 10 into 1 by, we can write minus of d square plus 6id by 10 plus 1 as 1 minus of d square plus 6id by 10 into x square. This is equals to imaginary part of e power 3ix into, we can write 1 by minus 10 as minus 1 by 10 into, and write this fraction as, see, this fraction is of 1 by 1 minus x form, so we can write it as 1 minus x whole inverse, right? And later we'll use binomial series expansion formula to expand this one. Okay, so we'll write this fraction as 1 minus d square plus 6id by 10 whole inverse into x square. Now we'll use 1 minus x whole inverse formula to expand 1 minus d square plus 6id by 10 whole inverse. So 1 minus x whole inverse is 1 plus x square plus x cube plus so on. Let's expand this using this formula, and before expansion let's find derivatives of x square. Derivative of x square is 2x, right? Now find d square of x square. D square of x square is derivative of x square. We have the value of derivative of x square, which is 2x. And again you can write this as 2 into derivative of x. We know that derivative of x is 1. So we'll get 2. Now find d cube of x square. D cube of x square is derivative of d square of x square. Since we have the value of d square of x square, which is 2, and derivative of a constant with respect to x is 0, right? We'll get d cube of x square is 0, likewise d power 4 of x square is 0, and so on. Higher derivatives of x square will become 0, right? In general, we can write it as d power k of x square equals to 0 for k equals to 3, 4, and so on, right? Expansion of 1 minus of d square plus 6id by 10 whole inverse is, by keeping all this in mind, we'll expand this one. Okay, just compare this two. Then for x equals to d square plus 6id by 10, we'll get 1 plus d square plus 6id by 10 plus d square plus 6id by 10 whole square plus so on, right? Which is equals to 1 plus d square plus 6id by 10 plus d square plus 6id whole square plus d square plus 6id whole cube by 10 cube plus so on. This is equals to 1 plus d square plus 6id by 10 plus d square plus 6id whole square by 10 square is 100. Expand d square plus 6id whole square. This is d square whole square plus 6id whole square plus 2 into d square into 6id, which is equals to d square whole square. A power m whole power n is a power m into n, so you will get d power 2 to the 4 plus 6id whole square. 6 square is 36 into I square into d square plus 2 6 are 12. I into d square into d is, add the powers 2 plus 1 3, you will get d cube, which is equals to d power 4 plus 36. We know that I square is minus 1, so you'll get minus 1 into d square plus 12i d cube, which is equals to d power 4 plus into minus minus 36d square plus 12i d cube, right? So expansion of d square plus 6id whole square is d power 4 minus 36d square plus 12id cube, right? Also you can expand d square plus 6id whole cube here. Okay, definitely you'll get higher derivatives from d cube. Okay, we can check it using a plus b whole cube formula. This is equals to a cube plus b cube plus 3ab into a plus b. Okay, I'll show you. We'll get a cube, that is d square whole cube plus 6id whole cube plus 3 into d square into, for b equals to 6id into a d square plus b 6id, right? So here you'll get d power 6 cube I cube into d cube, right? Here we got d power 6, here we got d cube, and here we'll get d cube into d square plus 6id. So we are getting higher derivatives, right? So we can neglect all the terms from here. Okay, we can neglect all the terms from here, and also terms higher derivatives d cube d power 4. We can also omit d cube d power 4 from the third term. Now coming to YP. Now I expand 1 minus d square plus 6id by 10 whole inverse into x square. Okay, expansion of this will be 1 plus d square plus 6id by 10 plus d square plus 6id by 10 whole square plus so on into x square. Right? We have used binomial series expansion formula. Right? And this becomes imaginary part of e power 3ix into minus 1 by 10 into 1 plus d square plus 6id by 10 plus d square plus 6id whole square by 10 square plus so on into x square. That's equals to imaginary part of e power 3ix into minus 1 by 10 into 1 plus d square plus 6id by 10 plus expansion of d square plus 6id whole square is d power 4 minus 36d square plus 12id cube by 10 square is 100 plus so on into x square, right? So from third term, so after third term, we'll get higher derivatives, completely higher derivatives from here. So we'll neglect all the terms from here and also we'll neglect d power 4 and d cube, since d cube and d power 4 are higher derivatives, right? Since d for k of x square is 0, for k equals to 3, 4 and so on. So neglect higher derivatives or higher derivative terms from d cube, d power 4 and so on. Okay. Then our yp becomes imaginary part of e power 3x into minus 1 by 10 into 1 plus 1 by 10 into d square plus 6id plus 1 by 100 into, also we are going to neglect d power 4 and d cube, right? So we'll get only the second term minus 36d square into x square after omitting all the higher derivatives. Yp becomes imaginary part of e power 3ix into minus 1 by 10 into 1 plus 1 by 10 into d square plus 6 by 10 into I into d plus into minus is minus 36 by 100 into d square into x square. Now write this constant towards left for our convenience. Minus 1 by 10 into imaginary part of e power 3ix into 1 plus 1 by 10 d square plus 2 3s are 6, 2 5s are 10, 3 by 5 id minus 2 50s, 2 1s are 2, 2 8s are 16, 2 9s are 18, 2 25s are 50, right? We'll get 9 by 25 into d square into x square. It is equals to minus 1 by 10 into imaginary part of e power 3ix into 1 into x square is x square plus 1 by 10 into d square of x square plus 3 by 5 into I into d of x square minus 9 by 25 into d square of x square is equals to minus 1 by 10 into imaginary part of e power 3ix into x square plus 10 into d square of x square is 2 plus 3 by 5 into I into derivative of x square is 2x minus 9 by 25 into d square of x square is 2, right? This is equals to 2 1s are 2 5s are minus 1 by 10 into imaginary part of e power 3ix into x square plus 1 by 5 plus I into 3 2s are 6 by 5 into x minus 9 2s are 18 by 25. yp becomes minus 1 by 10 into imaginary part of e power 3ix into x square plus I into 6 by 5 plus 1 by 5 minus 18 by 25. So let's simplify 1 by 5 minus 18 by 25. LCM of 5 and 25 is 25, right? So you'll get 25 as your LCM, and then in the denominator of first term we are having 5, so close 1 5 and multiply this 5 to 1, we'll get 5 minus in the second in the denominator of second term we are having 25, so we'll multiply nothing to this 18, so you'll get 5 minus 18 is minus 13 by 25, right? Then yp becomes minus 1 by 10 into imaginary part of e power 3ix into x square plus I into 6 by 5 x plus 1 by 5 minus 18 by 25 is minus 13 by 25. This becomes minus 1 by 10 into imaginary part of e power I 3x is, we know that e power I 3x is cos 3x plus I sin 3x by Euler's formula, right? Just write this, cos 3x plus I sin 3x. We'll just replace e power I 3x by cos 3x plus I sin 3x, okay, into x square plus I into 6 by 5x plus into minus 13 by 25. This is equals to minus 1 by 10 into imaginary part of cos x into all these three terms is x square cos 3x plus I into 6 by 5 into x cos 3x, right, minus 13 by 25 into cos 3x plus I sin 3x into x square is I, x square sin 3x plus into plus I into I square into 6 by 5 x into sin 3x plus into minus I into 13 by 25 into sin 3x now this becomes x square cos 3x plus I into 6 by 5 x cos 3x minus 13 by 25 cos 3x plus I into x square sin 3x plus I square is minus 1, right? So replace I square with minus 1. So you'll get plus into minus 6 by 5 x sin 3x minus I into 13 by 25 sin 3x. Now we need to find imaginary part of all these terms, right? So mark the imaginary terms. So we have three imaginary parts, right? Imaginary parts. Three terms exist in imaginary part of all these three terms. So this is equals to minus 1 by 10 into 6 by 5 x cos 3x plus x square sin 3x minus 13 by 25 sin 3x. yp becomes minus 1 by 10 into 6 by 5 x cos 3x plus, here take sin 3x common, you'll get x square minus 13 by 25 into sin 3x, which is equals to minus 1 by 10 into 6 by 5 x cos 3x plus take the LCM of 1 and 25, which is 25. In the numerator, you'll get 25x square minus 13 into sine 3x. YP becomes minus 1 by 10 into 6 by 5 x cos 3x minus 1 by 10 into 6 by 5 x cos 3x plus into minus is minus 1 by 10 into 25x square minus 13 by 25 into sine 3x, which is equals to minus 6. 3 2s are 6, 5 2s are 10, right? So you'll get minus 3 by 5 5s are 25 into x cos 3x minus 1 by 10. Okay, 10 into 25. 1 into 25 x square minus 13 is 25 x square minus 13 by 10 into 25 is 250 sine 3x. We can write this as minus of 3 by 25 into x cos 3x minus 1 by 250 into 25x square minus 13 into sine 3x. This is a required YP. Now we got YP and YC. Let's find the general solution. The general solution is given by y equals to YC plus YP. Then y equals to YC, we have C1 e power minus x plus C2 e power x, and YP is minus 3 by 25 into x cos 3x minus 1 by 250 into 25x square minus 13 into sine 3x. This completes the problem. So we have seen a problem from higher order linear differential equations in this video. Hope you'll understand. We'll see you in the next video. Until then, bye bye.